Next topic is the necessity of the complex number. Why uh, the wave function is the complex number. So before entering this one, I need to discuss one small information. So first, I'm going to discuss with the classical mechanics class. In classical mechanics, the motion in one-dimensional. So one the equation of motion we can write like this: the potential energy of the system is V of x, and this variable, the dynamical variable, is the position. The equation of motion is d square x of t divided by dt square equal to this one is a of, right? So force can be expressed in terms of potential energy minus derivative of potential energy with this argument. So here the position derivative with respect to time gives the one times gives velocity, and the double derivative is there gives the acceleration. So this term is the linear, and the potential term, the derivative of v, for example, this one is the x. So derivative of v gives to the x square. The x square function is a not linear. So it is complicated to solve the three-dimensional problem. So the Newton equation, this equation is a not linear. Okay, now come to the quantum mechanical case. Quantum mechanics is a linear. The Schrodinger wave equation is the IH cross dou psi divided by dou t. This is Hamiltonian wave function psi. So this is Schrodinger equation. I'm going to rewrite this equation like this: x comma t divided by dou t is equal to this Hamiltonian is kinetic energy plus potential energy. Here h is the this one h. Hamiltonian. This Hamiltonian operator is linear operator. So this Schrodinger wave equation is a linear equation. It follows the linear algebra. So we can apply linear operator, we can get the information of the system up to three-dimensional bodies. So here the complex number, here the I is the complex number. I is the complex number. The wave function is the complex number. So by using this complex number, so how we can derive the real, real the real parameters such as position and momentum, the electric field, these are the quantities are real. So how we are going to derive these real parameters? So what happen if psi is there real? So the complex number I is root minus 1. So in mathematical form, the complex number can be expressed like this: z equal to a plus ib. So this is belongs to the complex number. So here a comma b are the real numbers. The real part of this complex number is the a, and imaginary part of this complex number is b. So complex conjugate of this complex number z star, we can write a minus ib. So then norm of this complex form, this is x-axis, this is y-axis, this is a, this is ib. So the complex number, this one is z. The norm of this complex number, we can write z is equal to root of a square plus b square. So then z modulus of z square is equal to a square plus b square. So here the a square and b square I'm going to rewrite like this: modulus of z square is equal to z complex into z. So we know z, to multiply these two equations we can get a plus b whole square. The norm of this complex number is a real number. Then we can, so norm of complex number is a complex number. So this norm of the complex is the real number. So you can never measure the complex number, you measure only the real number in position and momentum. Max Born write this term like this: Max Born, so rewrite this equation like this: psi star into psi. This is the probability of the system. So here the, so wave function must be the complex number, and this equation is the linear equation. It's follow the linear algebra. So if it is follow the linear equation, we can scale up the things, we can measure the easily quantity of position momentum up to scale up the things. So here the wave function is here. So what happen if psi is real? So this wave function. If psi is real, what happened this wave function? Here the RHS side is the real and the LHS side is the imaginary part. So if psi is real, this one is psi is real here. So and here the RHS side is the real and LHS side is the imaginary. The real and the imaginary part cannot be equal, they are linearly independent. So this is also one of the reason a wave function psi is the complex. And this is the second reason wave function is the complex. Then we can get easily you can get easily measure the position, momentum, the real parameters.